This is a video of finding zeros of a polynomial function using long division. Slide 1 here is the warm-up. The leading coefficient of this polynomial is 4, right here. And the degree is x times x squared, which is x cubed. And here I multiplied everything out to show you what the polynomial looks like if I multiply everything together. X times x squared is x cubed, x times x is x squared, x times 2 is 2x, 3 times x, 3x squared, 3 times x is 3x, and 3 times 2 is 6. And then combining like terms of x cubed, x squared plus 3x squared is 4x squared, 2x plus 3x is 5, and then plus 6, and then multiply everything by 4. So 4 times x cubed, 4x cubed, 4 times 4x squared, 16x squared, 4 times 5x is 20x, and 4 times 6 is 24. To get the end behavior, I look at the leading coefficient as positive, the degree is odd, so the left side goes down as x approaches negative infinity, f of x approaches negative infinity, and the right side goes up. So as x approaches positive infinity, f of x approaches positive infinity. The zeros, you equate the factored form, each factor to 0, so x plus 3 equals 0, or x squared plus x plus 2 equals 0. Solving this equation, you get x equal negative 3. To solve the quadratic, you're going to use the quadratic formula where x, so let me say that again, where b is 1, so the opposite of b is negative 1. 1 squared is 1, and then negative 4 times my a value is 1, and my c value is 2, and then 2 times a in the denominator, 2 times 1 is 2. So when I simplify this, negative 1 plus or minus the square root of negative 7 is I root 7. So negative 1 plus or minus I root 7 over 2. Slide 2 is the objective. Students be able to find the zeros of a polynomial function using long division. Some of the terms that we need to think about are remainder theorem and factor theorem. Remainder theorem says that if you divide a polynomial f of x by a linear expression, x minus a, the remainder will be the same as f of this value a. The factor theorem states if f of some value is 0, then x minus a is a factor. So today we'll look at the graph of a polynomial function, find one of the zeros, then we'll use the factor theorem and long division to get the polynomial in factored form, then find the remaining zeros. All right, here's an example. So here's a polynomial function graphed, x cubed minus 3x squared plus 6x minus 18. If I click on this 0 here, it's at 3, 0, so x equal 3 is a 0 because the graph crosses the x-axis at 3, 0. And if I evaluate this function at 3 cubed minus 3 times 3 squared plus 6 times 3 minus 18, I get a 0. So the remainder theorem says if f of some value is 0, then that's the 0 of the function, and then the factor is x minus this value. So x minus 3 is a factor of this polynomial. That's the factor theorem. So if 3 is a 0, then x minus 3 is a factor. That's the factor theorem. In order to get f of x in factor form, once we get f of x in factor form, we'll find the other two zeros by using the zero product property and the quadratic formula. So here's the original polynomial here under the division box there, and then one of the factors is 3, so x minus 3, or one of the zeros is 3, so a factor must be x minus 3. So in order to do long division, we do x divided into x cubed, we get x squared. Then multiply x squared times x is x cubed. X squared times negative 3 is negative 3x. Then we subtract these terms, I get a 0. And we bring down the rest of the terms, 6x minus 18. And then do x divides 6x 6 times. 6 times x is 6x. 6 times negative 3 is negative 18. And so we get a remainder of 0 there, and we should, because we said if this is a 0, then x minus 3 is a factor. We'll get a remainder of 0 there. So once again, here's the steps written out. X cubed divided by x is x squared. Place the x squared above the negative 3x squared. And then multiply x squared times x minus 3. X squared times x is x cubed, and x squared minus times negative 3 is negative 3x squared. We place the result under the corresponding powers of x. So here's the third power, place it under the third powers. Second power, place that term under the second power term, and then subtract. So in this case, when we subtract these two expressions here, we get 0. And then bring down the rest of the terms, so 6x minus 18. Repeat the process of divide, multiply, subtract, bring down until I end up with expressions with a degree less than the divisor, a remainder, some integer value, or 0 as a remainder. In this case, we're doing 6x divided by x. So this divided by this is 6, and then 6 times x, 6x. 6 times negative 3 is negative 18. Subtract again, you get a 0. So multiply 6 times x minus 3, the result is 6x minus 18. Put this under the corresponding power of x. Subtract, in this case, we get a remainder of 0 here when we subtract those. So the division algorithm is divide, multiply, subtract, bring down, repeat the process until you get a remainder which is less than the degree of the divisor, an integer remainder, or a remainder of 0. Every problem today that we use long division on, we're going to get a remainder of 0. The mnemonic device you can use is Dead Monkeys Smell Bad. So D, dead is divide, M, monkeys, M, multiply, smell, S, S, subtract, B, bad, B, bring down. You repeat that process until you can't do it anymore. You get a remainder, a number remainder, 0 remainder, or a remainder that's less than the degree of the divisor. So f of x in factor form, x minus 3 was one of the factors. And then up here, the other factors, x squared plus 6. So equate each factor to 0, get x equal 3, or x squared plus 6 equals 0. Subtract 6 from both sides, and then take the square root. So you get the square, plus or minus square root of negative 6 is plus or minus I root 6. And the other 0 is 3. So we have the degree 3. The three zeros are x equal 3, x equal I root 6, and x equal negative I root 6. On slide 5, we want to find the 0. Here it is, 9, so that's why I put a 9 in there. And then we're going to use long division. So did this one in class, but I'll do it over again here. So x cubed minus x squared minus 7x minus 18. We'll put that under the radical here. Or not under the radical, under the division box. X cubed minus 8x squared minus 7x minus 18. And like I said up here, you can do this work in the sketch box here or get another piece of paper. So if 9 is a 0, then x minus 9 is a factor. That's the factor theorem. So the first thing we're going to do is the x divided into x cubed goes x squared times. I want to put that above the negative 8x squared. Now multiply x cubed, or x squared times x is x cubed. X squared times negative 9 is negative 9x squared. We're going to subtract these two terms from the two terms that are above it. X cubed minus x cubed is 0. Negative 8x squared minus a negative 9x squared is the same as negative 8x squared plus 9x squared. So you get 1x squared here. And then bring down the other terms here. And then x divides x squared x times. Put plus x here. And x times x is x squared. And x times negative 9 is negative 9x. We'll subtract those. X squared minus x squared is 0. Negative 7x minus a negative 9x is the same as negative 7x plus 9x. You get a 2x here. Bring down the negative 18. And then divide x into 2x. You get a 2 here. And multiply 2 times x is 2x. And 2 times negative 9 is negative 18. So I get a remainder of 0 there, which I should. And then here's the polynomial in factored form. F of x equal x minus 9 times x squared plus x plus 2. And then to find the zeros, equate the both factors to 0. X minus 9 equals 0. When I solve that, I get x equal 9. And then to solve this quadratic, a is 1, b is 1, and c is 2, plug in the quadratic formula. Opposite of 1 is negative 1. 1 squared is 1. Minus 4 times a is 1 and c is 2. Divided by 2 times a, which is 2. And you have negative 1 plus or minus. 1 minus 8 is negative 7. So plus or minus the square root of negative 7 is plus or minus I root 7 over 2. So the three roots are 9. Second root, negative 1 plus I root 7 over 2. And the third root is negative 1 minus I root 7 over 2. And then on slide 6, find the 0. So you're first going to click on here. And my 0 is 2, 0. So my integer 0 is 2. That means x minus 2 is a factor. So we're going to divide. Let's make a division box here. You get the pencil. So we're going to divide this original polynomial, x cubed. Let me make that a little bit better. Get the undo button here. x cubed minus 8x squared plus 22x and then minus 20. And then I'm dividing by x minus 2. First thing I'm going to do is x divided by x cubed goes x squared times. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Then subtract these two terms. X cubed minus x cubed is 0. Negative x squared plus 2x is negative 6x squared. Bring these terms down here. And then negative 6x squared divided by x is negative 6x. Negative 6x times x is negative 6x squared. Negative 6 times negative 2 is positive 12x. And then subtract these two. Get a 0. 22x minus 12x is 10x. Bring down the negative 20. And then x divides 10x 10 times. 10x. And 10 times negative 2 is negative 20. If I subtract those two, I get a 0. So the factored form, x minus 2 times x squared minus 6x plus 10. Equate each factor to 0, x equal 2. The second expression is quadratic, so we use the quadratic formula. A is 1, B negative 6, C is 10. So opposite of negative 6 is positive 6. 6 squared is 36 minus 4 times 1 times 10 over 2. And then 36 minus 40 is negative 4. So 6 plus or minus 2i over 2 is 3 plus or minus I. So the 3 factors 2, and then 3 plus I and 3 minus I. So you get 3 answers there. Here's the polynomial in factor form, x minus 2 times x squared minus 6x plus 10. So here the integer value is 2 again. So let me type that in here. So we're going to do long division on x cubed minus x squared minus x minus 2. So in the division box here, x cubed minus x squared minus x minus 2, divide by x minus 2. So if 2 is a 0, x minus 2 is a factor. X divides x cubed, x squared times x squared times x cubed. X squared times negative 2 is negative 2x squared. I'm going to subtract these two terms. Negative x squared plus 2x squared is positive x squared. Bring down the other two terms. X divides x squared x times x is x squared. X times negative 2 is negative 2x. And then subtract these. 0, and then negative 2 plus, or negative 1x plus 2x is x. X divided x one time. We get x minus 2. Subtract, get a 0. So the polynomial in factored form f of x equals x minus 2 times x squared plus x plus 1. So to find the zeros, equate each factor to 0. 0 equals x minus 2 times x squared plus x plus 1. And then equate each factor to 0. So x minus 2 equals 0, or x squared plus x plus 1 equals 0. X equal 2. To solve the quadratic, plug in the quadratic formula. So opposite of 1 is negative 1, plus or minus. Whoop. Wrong keys there. Uh, 1 squared is 1, minus 4 times a is 1, and c is 1, and then divided by 2 times 1, which is 2. Get x equal negative 1 plus or minus square root. A 1 minus 4 is negative 3, so the I goes in front of here. And divided by 2. So 3 roots of 2, x equal negative 1 plus I root 3 over 2, and x equal negative 1 minus I root 3 over 2. Slide 8. You want to find the integer 0. So that's not an integer 0. That one's not. So 3, 0 is the integer 0. And then you want to do x minus 3 divided into x cubed. So let's make a division box here. X cubed minus 3x squared minus 3x plus 9. And you're divided by x minus 3. So if 3 is a factor, and let me say that again, if 3 is a 0, then x minus 3 is a factor. And then you want to do x divides x cubed, x squared times, multiply. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Subtract these two. You get 0. Bring these down. Then x divides negative 3 times. 3 times x, negative 3x. Negative 3 times 9 is plus 9. Subtract those, you get 0. So the factored form f of x equal x minus 3 times x squared minus 3. And then equate each factor to 0. And then we have x minus 3 equals 0. This should be minus here. Make sure I have it right here too. It's right there. So solving these two equations, x equal 3 or x squared equal 3. You can solve the second one by taking the square root there. So the 3 zeros is x equal 3, x equal square root of 3, or x equal negative square root of 3. So if you go up here, this is actually an approximation for the square root of 3. And this is the approximation for a negative square root of 3, or the negative of the square root of 3. This was the integer 0 there. So slide 9 is the exit ticket. You can do that one on your own. And then slide 10 is the challenge problem. You want to find the two integer zeros. That's not 1, that's not 1. So 3, 0, and 7, 0. So 3 and 7. And then use one of the zeros and then the second 0. So this time we're going to divide twice. So one of the zeros is 3, so x minus 3 is a factor. And x to the fourth minus 8x cubed minus x squared plus 62x minus 42. So the first thing we do is x divides x to the fourth, x to the cube times, and multiply x to the fourth minus 3x cubed. Subtract these. Negative 8 plus 3x cubed is negative 5x cubed. And then bring down the other terms. And then negative 5x cubed divided by x, negative 5x squared. And then multiply negative 5x cubed and negative 5x times negative 3 is positive 15 x squared. Subtract. Negative x squared minus 15x squared is negative 16x squared. Bring down the other terms, 62x. Oh. Minus 42. And then x divides negative 16x squared, negative 16x times. This is getting a little messy and crowded here, but so negative 16x squared. And the negative 16x times negative 3 is plus 48. And then subtract 12 minus 48 is negative 36. And bring down the negative 42. And then negative 36 divided by negative x here. Something went wrong here. Oh, that's a 62. That's what's wrong. So let me erase this. 62 minus 48 is 14, maybe. Yeah, 14. 14x minus 42. And then 14x divided by x is 14. That's a little messy here. 14 times x, 14x. And minus 42. So this is hard to read, but x cubed minus 5x squared minus 16x plus 14. So now we want to take this polynomial here and divide it by x minus 7. So what goes in the division box here is x cubed minus 5x squared minus 16x plus 14. And you want to divide that by x minus 7. So x divides x cubed x squared times multiply subtract. And you get a 2x here. Multiply. Subtract. So negative 2x plus 14. You get a negative 2 here. So the factored form. So to the factors, you get by the integer factors here, x minus 3 times x minus 7 and then the final factor is right here, x squared plus 2x minus 2. So equate each factor to 0. Under here. It's right here, x squared plus 2x equate each factor to 0. I get x equals 3, x equals 7, and then you need to use the quadratic formula. The quadratic here, so the opposite of 2 is -2, plus or minus square root 2 squared is 4, minus 4 times 1 times -2. Oops. It keeps happening there. Divided by 2 times 1, which is 2. And you need to simplify this here. Four and -4 times -2 is 8, so square root 4 plus 8 would be 12. That could be simplified further by simplifying this, but I'll just leave it like that. So the 4 roots, 3, 7, -2 plus the square root of 12 over 2, and -2 minus the square root of 12 over 2. So just to show you what it would look like if I simplified this further. -2 plus or minus, and the square root of 12 is 2 root 3. Over 2. And then divide everything by 2. So I got -1 plus or minus square root of 3. So 3, 7, -1 plus the square root of 3, and -1 minus the square root of 3.